Thanks. Hi, everybody. Thanks for having me. Thanks to be here for this talk about containerizing application and specifically Java application. I am Nicolas Frankel. Before I was a developer advocate, I was a developer, I was a team lead, I was an architect. Well, I've always worked in technical roles, and I'm very curious right now about the whole stuff about Dockerization and Kubernetes. I currently work for a company called Hazelcast. Hazelcast has two products. Our first product was an in-memory data grid, and you can think about an in-memory data grids as distributed data structures. So if you have like a map or a dictionary or whatever you call it in your language, then it's not limited to your own machine, but it can be distributed all over the network so that the data can be shared or replicated. And the second product is called Hazelcast Jet. It leverages the IMDG in order to do stream processing in memory, and again, distributed all over the network. We are right now participating in Oktoberfest, so if you want to join us, then we will be more than happy if you came. Containerizing application. So if you want to containerize a Python application, it's quite easy. You just take from the Python 3 or 2 if you are stuck. You get your requirements.txt, you install the dependencies, and then you just add the script, you run the script, you're done. That's super straightforward. If you do the same for a Node.js application, well, that's exactly the same. Perhaps if it's a web application, you expose some ports, but in the end, again, same stuff. You copy the dependency, whatever, you install the dependencies, and you've got everything. The easier part about those scripting languages is there is no intermediate compilation phase. So you just download the dependency, and basically what you see in the script is what will get executed. So it's quite easy. Now, if you are building a Java application, and it can be a .NET application, a Scala application, a Kotlin application, whenever you need to actually compile that, you still need to download the dependencies, obviously, but you first need to have this compile phase that will take, I will talk about Java apps because that's what I'm most familiar about. That takes the .java file and compiles it to a .class file. And in general, you use this to package a specific structure, specific archive, just a zip file, but in the Java world, it's called a jar. And in traditional stacks without containerization, that's what you deploy, that's what you deliver. So some of them can be self-executed, some others can be deployed inside of other containers, such as application servers, but you have those two additional phases. And if I copy-paste the script from the scripting language, this is my Docker file. So I will just get from a Maven image. I forgot to copy the sources, and I forgot to copy the pom.xml. So here, just put them in your head. Then I run the mvn package, and finally I can execute the java.jar. And I assume this is a self-executable jar. This approach works, obviously. It has a couple of issues. The first one is, since we are using a JDK to compile, the final image, we also embed a JDK. That means that first, the image size will be much bigger than expected because a JDK is bigger than just a Java runtime. More importantly, it can compile Java codes, and this is a huge security issue. I'm not sure you want in production to have an image that can compile Java code, because I can send it Java code to be compiled that might do some bad stuff on the machine. So you don't want that. Second issue is the version handling. Here I say, okay, it's XYZ because I know that the pom.xml contains XYZ version. So I need to map myself in my head the fact that the POM is of version X and the image will be of version X. There is no automatic version handling. So I could potentially easily have a POM of version X and have an image of version Y. Not great. And finally, there is no layering. That means that I will have a single jar in the final image. And if I need to change a source, all these layers will need to be rebuilt. That is not so great because sometimes I would just need to change a configuration file or just need to recompile one class. And again, I will need to get all the dependencies. And that's actually what takes the most time, and recompile everything. And that's not super good idea regarding the velocity of the development. So there is an alternative there. You can create the jar outside of Docker. So let's try to do that. Here, I have my first application here. So I have a simple Spring Boot application. It doesn't do anything really smart. I just connect to an Hazelcast cluster. And then I have a controller and I have two mappings. The first one puts data into Hazelcast through the client, and the second one gets the list of all clients. Easy peasy. And because I'm super lazy and I don't want to do like bad demos, this is my first try for this talk, so I didn't want to take any risk. So what I did is I recorded everything. So here I show you how I do it. I clean the repository outside of Docker. I package it outside of Docker, and then I build using this Docker file. So basically, this Docker file just takes the jar that has been created outside of Docker and puts it into the container. And afterwards, I just try to use it. I curl, I add one entity, and then I check that everything has been set, and this is the result. And in the end, I just stop the container. So not so great, because every time I need to build something, then actually I need to package it outside of Docker. So the first normal thing would be to do like this. And this is the next step. Actually, I need to do the entire build outside of Docker. This is the result. You've got the same result. Of course, now it takes a bit more time, and I've got everything. Still works. Here I'm packaging without the tests, and I've got my final jar. As I mentioned, you've got a couple of issues. For the record, sorry. I've got a REST endpoint in my Spring in Docker jar. Inside, I have this Hazelcast client that does like calls to the Hazelcast stuff. Again, not that great. Here, I embed a JVM, so security issue, no version handling, no automatic version handling, and no layering. Not great. So the next step to get a bit better is at least to use a multi-stage build. So multi-stages builds, they are good because they allow you to have different images regarding your builds. You can have inside your Docker file section that is dedicated to building and one that is dedicated to running using this copy -- from. It's pretty widespread. The issue is it's not compatible with scaffold. So there is still an issue that is open. Scaffold is this automatic checking of changes in your sources that the image gets rebuilt automatically and deployed to a Kubernetes cluster. In general, you do it on your local machine. You use Minikube or K3 or whatever. And every time you do a change, then it gets redeployed automatically. And unfortunately, this is not compatible with scaffold. However, it works much, much better because at least here, you've got this like GDK that will build the stuff. And then you've got a GRE that will run the container. That makes at least the issue about embedding the GDK non-existent anymore. So here I have my, here I have my Docker images and I have already built everything. And this is version 1.1. So here you can see that if I dive into this one, takes a bit of time, and this unfortunately cannot be prepared beforehand. Here you can see that I'm using a normal, I'm using the normal system. And then if I just show the stuff that has not been modified, I have my GDK. And finally, I have the Spring in docker.jar. So it's a bit better. And if you want to check, you can also check that here, for example, I have tagged it. Normally they are not named, but I have tagged it for like checking purposes. You can check the images that was used to actually build the second image. And here you can see that I added the Maven wrapper, that I added this script, that I have added the POM, that I have added the source, and then that I did the package. So it's marginally better. Still, we can do better because now we still have the same issue that before. If we have changes, then basically the layers is just a single jar. So what we want to do is to have a layer multi-stage build so that when we build it, first we get the dependencies and then we've got the sources. So if I change the source, I will still be able to reuse this layer of dependency. Again, let's dive into it. And now we can see all those layers. You still have the same ones. But here you've got the dependency layer, which is 100 megabytes, and the source layers, which is 54 kilobytes. Now imagine that if you don't have this layer stuff, every time you need to change a source, you will reload your dependencies. That's not what you want. So this way, if you change your source, this layer will still be valid. Of course, if you change your dependency, it won't be valid anymore, but that will always be the case. But here, that means that I can just change the source and I will just need to execute the build process. And this will be kept. So it's much, much better. The next problem we want to address is the lack of synchronization between your POM version and your image version. As I mentioned, here I say, hey, Docker build blah, 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 and I need to tag it explicitly because I know that I will be using this jar. But here, if I'm changing, if I'm like making a typo, I can type 1.3, 1.4, 2.0, whatever, and it can get me the wrong version, the wrong tag on my Docker image. The next step, the alternative, is to use something called Jib. And Jib is actually a Maven plugin that you just put into your POM. And by default, it's able to push to a remote Docker repository or to your local Docker daemon. You've got a lot of configuration options. For example, you can choose your parent image. And it's smart because it doesn't try to run the job. I mean, think about it. If you are not in a container world, your jar is the unit of deployment. So it needs to be a single archive. Once you've got the container, your container becomes the unit of deployment. And in that case, what's inside, whether it's a single jar or it's exploding in classes and resources and whatever, it's not that important. So this is a very, very good idea, actually. So the benefits is there are no Docker files. It's an automatic version handling from the POM. And you've got 3 layers. You've got the dependency layers, you've got the resources layers, and you've got the compile code layer. So again, it does it for you automatically. Let's see how it works. I will dive into the Spring Boot 2.0, which is the Jib one. And as you can see, it's from Google. They are using Bazel. And here you can see the layering of Jib. So the first layer is actually the libs. The second layer is the snapshots. The third one is the resources. And the final one is my code. So if I change my code, I will keep my resources. If I change my resources, I will the libs. So I think that at this point, we are very happy and we could stop there. But actually, let's talk a bit about the snapshots. We are using a Spring Boot application. Let's try to use this layer-aware multi-stage builds for ourselves. And we will do manually what Jib did for us. So basically, the layers will be, again, the same one, but it will be a different order. It will be first the dependencies, and then the resources, and then the snapshot dependencies, and then the compile code. And the reason for that is that snapshot dependencies, they might change every time. I mean, perhaps you are not aware of that, but snapshots dependencies are just like they have a tag, but the content it can change in time. So they are very unstable. You should never deploy something with snapshot dependencies, but here it's for the sake of the argument. And also when you are developing, it might be the case that you are using snapshot dependencies. So how does it work? Here I have a Docker file again, and you can see that I kept the dependency stuff in a single image. And now when I'm building, I'm trying to be smart. So basically, I'm using a GRE to copy the jar from my previous builds. And then I'm using the Spring Boot feature that is able to take this jar and explode it again into different layers. And then on the final step, I just add all those dependencies by myself in the order that I want, and I get the result. So let's dive into it again, and it should be called 3.0. Here, I've got the dependencies that I wanted, and in the order that I wanted. So here, my sources, here, Spring Boot itself, here, the snapshot dependency, and here, dependencies. The good thing about is that I can change the order. Like for whatever reason, I know that, I don't know, that the snapshots will be changing very often. I can put it in a top dependent. Well, here it would be the bottom, but it will be a top dependency, top layer. So it's not an issue if I discard it very often. It's up to you. You can also do your own layering. It depends on what you want to do. Here, for example, you have this layer.edx. It's a configuration file, and you can do whatever you want. And if you check Docker images grep Spring, you can see the builds, because here I have like one build and the second build image, and I've referenced them as 3.0a and 3.0b. So let's check how it works. I mean, this one is the most important one. It's dive 3.0b. And you see here that it starts from having a jar and it explodes it into different places. And then the next step is to get those places and to say, hey, here I will put them into the final image with those layers. Great, that's a bit better. But we get back to Docker files. That's what I mean, again, we've got this problem of synchronization. I need to know which version I'm containerizing, so I'm not super happy about that. Another alternative is to use Buildpacks. Perhaps you've heard about Buildpacks. Buildpacks, you just say, hey, I want to use this Buildpack, and it gives you a general idea, like it might be a Java Buildpack. And then the Java Buildpack will like sniff your project, and it will understand by itself which builders it will need to invoke. So it will say, this as a pom.xml file, it must be a Maven project. Or, oh, it has a Gradle build file, so it must be a Gradle project. And I will respectively invoke the Maven builder or the Gradle builder. They are based on an old idea of Heroku. I don't know if you have ever used Heroku, but basically you could upload your sources to a Git repository on Heroku, and the Heroku platform will like sniff this stuff and will build the correct package and deploy it. It was quite interesting, and now it is backed by the CNCF. So Heroku and VMware, they are at the lead of this initiative, and it's a CNCF project. So there are a lot of configuration options, the main one being the builder. Good things is you've got no Docker file, it's Docker friendly, and you've got the previous 4 layers. So, I mean, it could be the final solution. Still, there are some downsides. So basically, again, you've got no version handling automatic. So you need to think about the correct version. Something very important with Jib and with the Docker file, you can choose the parent image. Here, the parent image is chosen for you. So it can be a huge image that you don't need to. It can be a huge image that has like a bigger, a wider attack surface. Not super great. What I've also noticed is that even if you had no changes, the process will run every time, and it can take a while. The reason for that is that it seems, as of now, the image that are used during the build, they are not cached. So basically, every time it will need to download the JDK. worst that I didn't write because I was a bit ashamed. I still tried yesterday. I used a specific builder. It was a tagged version 0.3. And basically, like 1 week ago, it worked. And this week, I tried it again, and it didn't work anymore. So basically, the tag means that it's not immutable. They are changing the stuff meanwhile. And I believe that's really, really, really bad. Let's try, because I just want to have fun. It's called, yes, something like that. And I just want to show you, I mean, so here it will probably fail because it tells me that the image are up to date. But here you see that I'm using no snapshot dependency. I'm using the 0.3 and they change it meanwhile. So here what is interesting is they are checking that actually what is my project. And it says, oh, it's a Maven. Oh, it will run in Apache Tomcat. Oh, there is a Spring Boot project, this kind of stuff. And of course, here it tells about the GDK. So I believe that's very interesting way to go if it works. Right now, for me, it's not stable, completely not stable. The next stuff will be about the CLI itself. Sorry, the Buildpack. So the final solution is to use the Spring Boot Maven plugin. So instead of having an external command line, this pack command, you have a dedicated call from the Maven lifecycle. And you've got, again, a lot of configuration options. And I think that's quite good because you've got no Docker file to handle. It's layered. The POM and the Docker image version are in sync because it's inside of Maven. That's pretty cool. But you have no choice of the parent image. And how does it look like? It looks pretty impressive, actually. As you can see, there is no Docker file anymore. And the POM, I just needed to add the latest Spring Boot. So basically, I'm using a version of Spring Boot that is not released yet. And if I run it now, so again, I did that yesterday because I don't want to run into demo issues. Play, it's version 4. Nope. Nope. NS, no, it's version 50. So I just need to invoke this build image stuff. And it's all it does. And again, you can see that here it does the same. So it pulls the same pack file and it checks. Like here, for example, I change it to use GraalVM. So it tells me, hey, I will use GraalVM. I will use an executable jar. I will use Spring Boot. I will use Spring Boot native image. And then you've got the same stuff. Very important, it takes ages because here I'm doing it for GraalVM. So if you compile for GraalVM, you are taking the jar and the bytecode, you transform it to a native. And finally, well, it takes a long time. But actually, it works and it's very configurable. You might think that flattening the layers just before deployment might be a good idea. I've checked, I've used something called Docker Squash. So basically, you like get the Docker image, you get it into a tar, and you create a Docker image out of it again. So you remove all layers. For the version 1.0, so the first version that I showed you, I've got a very marginal gain. And on this last one, I got less than 1% of gain in size. So I'm not sure flattening layers is a really great idea. But I mean, it depends on your issues. but it's just like a wrong good idea. So in this talk, I try to address some issues that you have when containerizing your Java apps. The one is how do you sync your version between the POM and the image? How do you organize your layers for faster development? And I try to show you that Squash is not super useful in the end. Here, these are the final. So here you see I have a Go issue when I'm trying to use the Buildpack with the CLI. Not great, not a good idea. Docker images, grep Spring. So this is my 5.0, which has been squashed. And actually, as you can see, it's 182. And the 5.0 that has not been squashed is 184. So not great, not super huge advantage. However, from going to a normal jar to a native executable, it goes from like 260 megs to 180 megs. So that's quite interesting. So if you want to have a slim image, then I would encourage you to do the GraalVM stuff instead. Okay, this is all, folks.